This video is going to be on lambda expressions, which are one of the new features that come with Java 8. So first we're going to take a look at functional interfaces, which are what lambda expressions actually represent. Then we're going to create instances of that functional interface through regular classes and also through an anonymous class. And then lastly, we're going to really understand how a lambda expression works by creating instances of our functional interface within a lambda expression. And we're also going to play about a little bit so you can understand a little bit more on how a lambda expression can be represented. If you find this video helpful, please give it a thumbs up. And if you want to see more weekly videos on Java and other software engineering topics, please consider subscribing. Okay, so the first thing I'm going to do is create a functional interface, and this is just like any other interface, except it only has one abstract method. So I'm going to call this interface engine, just like the engine of a car. And the functional interface will have just one abstract method. So for our case, we're just going to return an integer. I'm going to call the method compute power. And this abstract method will have no method body. So whenever a class implements this interface, it will have to override this compute power method. And all abstract methods within an interface are inherently public. So if this wasn't a functional interface, it would have more than one abstract method, such as string, get name. So this is no longer a functional interface, so I'm just going to remove that. But having said that, the functional interface can have other methods that have the method body, so they are not abstract. And one example might be using the default keyword. It will return void, we'll just have make sound, and this can have its own body and method. I'll do another video on the default keyword, which allows backward compatibility with Java 8 interfaces, but the main focus here is on the lambda and functional interfaces. So we have our engine interface here. It has one method, and the first question you might want to ask yourself is, how do we go about creating an instance of this engine interface? So I'm going to create a new class, and I'm going to call it Rolls-Royce. Rolls-Royce will implement the engine interface. So if we implement those methods, we have to override the compute power method, and let's say we just want it to return 10. And then I have this application class already made with the public static void main method. So I'm going to create a new instance of the Rolls-Royce. Then I'm just going to print out Rolls-Royce compute power, and now we can run this application, and we can see that the number 10 has been printed to the console. So you might think that this is quite a long way of going about an implementation of just this single method. You know, we're creating a whole brand new class, we're overriding the method, and then we're going to create an instance of the class and then call that method. So there is one easier way that we can go about this, and that's by creating an anonymous class. So I'm just going to delete this Rolls-Royce class. Now, an anonymous class has syntax that is very much like invoking the constructor of a class, but the class definition is contained within a block of code. So instead, we're going to have engine Rolls-Royce equals new engine, and then what we've done here through the anonymous class is overridden the only abstract method that we have within the engine interface, which is that compute power. So once again, we can just return 10, and then I can system out the Rolls-Royce.compute power. And this is fairly similar to the first way that we created a new instance of our engine interface, which was through the actual class, whereas now we're using an anonymous class. So once again, we have the number 10 printed to the console. Now the third way that we can go about creating an instance of our functional interface engine is through a lambda expression. And it's quite hard for me to describe a lambda expression in front of you. So what I'll do is I'll write one out. So we'll call this Rolls-Royce lambda. And all it is a very simple line, these parentheses followed by an arrow sign and then the number 10. I'm just going to now print out Rolls-Royce lambda down below so that we can see it working. So we can see the number 10 is printed out to the console twice. So how do we go about actually creating this lambda expression? So whenever we're using a lambda expression, it will always be referencing a functional interface. So the engine interface that we have has just one method. Firstly, it takes in no parameters within that method, and secondly, it returns an integer. So if we head back into our application class, we've represented this entire functional interface with just a single method. So here we're saying compute power doesn't take any arguments, and then secondly, it returns the number 10. And then down below, when we've accessed our instance of the engine Rolls-Royce Lambda and call the only method that it has overridden, which is compute power, it knows exactly where this implementation of compute power has come from. It's come from this lambda expression. So I'm just going to clean this up, take out the anonymous class, and we can dive into the lambda a little bit more. So let's say if we go to our engine class and stop it being a functional interface, so we have a new abstract method, getName. This interface is no longer a functional one because it has two abstract methods. If we go into the application and we can see that we're trying to call a lambda expression on our engine interface, it's going to throw us a compile error. And that's because engine isn't a functional interface, so it doesn't know which abstract method this will actually be representing. So I'm just going to remove that getName. And now let's say our compute power takes in a couple arguments. So the first could be integer base value, and the second could be integer multiplier. So now when we define our lambda expression, we're going to be passing in two different variables. So first we'll be passing in the base value, and second the multiplier. Now what we're doing here within this lambda expression is telling this instance of engine, which is called Rolls-Royce Lambda, how to handle the base and the multiplier. What we have here is that no matter what these two variables are, we're always going to return the number 10. So if I pass in the number 1 and 2 and run the application, we can see that the number 10 is being returned back. An alternative would be to multiply these two numbers together. So we can have base multiplied by multiplier. And now if I run the application one more time, we can see that the number 2 has been returned to the console. Now when we're defining our lambda expression, it doesn't always have to be on a single line. In fact, it can be multiple lines as long as we're capturing them within curly braces. So if I just add curly braces here and add the return method, we can now see that we can have a lot more logic being processed by our lambda expression across multiple lines, provided we've captured it within curly braces. So we might have a new integer called multiplier squared, and that equals multiplier multiplied by multiplier. And then we might want to return the multiplier squared. So 1 times 2 times 2, so we expect the number 4 to be returned to the console. And we can see the number 4 has been returned to the console. Just to play about a little bit more, let's say we want to return a string from our compute power method. Within our lambda expression, we're now returning an integer, whereas within the engine functional interface, we expect it to return a string. So let's just say we're returning. So now when we call this compute power method, the implementation of it has come from our lambda expression above, and we can expect Rolls-Royce just to be printed in the console down below. And we can see that we've now adapted our lambda expression to reflect upon the single abstract method that we have within our functional interface called engine. So the first benefit we can see to lambda expressions is that they can be very concise. They can be really easy way for ourselves to create implementations of a functional interface within the actual code block that we're then going to be using it. Now Java 8 also introduces quite a few functional interfaces and for us to use within our application, But I'll be making this in a different video because that's quite a larger topic. But within this video, we've been able to look at firstly what a functional interface is, where we just have a single abstract method, not 0, not 2, but only ever 1. And then secondly, how we can create instances of that functional interface, whether it be through a class, through an anonymous class, or in our instance here by creating a lambda expression where we define the arguments that are being passed into that single abstract method within the parentheses here. We have an arrow sign, and then we have the implementation within curly braces, or if it's all on the same line, we don't need the curly braces and the semicolon at the end.